Hello, humans of the internet. It is I, Dead Program, along with Gopherbot, here in our season finale episode at La Pipa live in Asturias, España. I've now been fully vaccinated, as has Gopherbot. So we're actually, Gopherbot, you could take off your mask too if you really want. Like, yeah, let's do that. Okay, Gopherbot takes the mask off. This is incredible. This is the first time Gopherbot's had the mask off in months. Wow. I mean, it's not over yet, but at least we're not too bad off here. So, my dear friends, we have some really cool stuff for you today. Basically, last time it was a cliffhanger as we completely failed to get the revamp of our new tiny drone flight controller working. So with that, terrible crisis of confidence on our hands, we go back at it again today. But first, a bit of news from the world. So if you've been following along with the brilliance of the Mars helicopter, so the next one is going to be even more brilliant. And of course, it's all going to be completely open source. So this was going to be open source all the way along the line, right? But they're basically planning right now to build it all from open source hardware and software from scratch. So that's pretty exciting. We'll give you more updates on that as they occur. Here on Earth this last week, not necessarily my favorite of companies for various reasons, but Facebook always can be counted upon to do some really interesting things engineering-wise. So this week, they have an open source time appliance. So this is actually open source hardware and software that's designed to communicate with the same type of latency calculations that the GPS satellites use. And utilizing those drift calculations, come up with a time server, or a time appliance rather, that instead of using the NTP time protocol with its maybe, millisecond accuracy, instead we're talking about, as they're claiming, nanosecond accuracy. Where is the stat on that? Let's see here. They tell you right up in the beginning. From 10 milliseconds to 100 microseconds. Okay, not nanoseconds, sorry. Microseconds. Well, that's a pretty incredible difference as far as our ability to synchronize different devices across geographic time zones, other sides of the planet. So very cool stuff going on there. Awesome work. So in the world of TinyGo, there's been a couple of really awesome projects that have been worked on by amazing members of the community. Aurelie Vache has done a whole series of posts about learning Go by example. And this week, their post is creating a Game Boy Advance game. So this is actually a really awesome post that goes really deep as far as how to use, of course, TinyGo, since that's the only Go you can run on the Game Boy Advance, naturally. And it goes through the entire set of steps that you need to do in order to actually create something that runs on, if I scroll down, the real live actual hardware. Where's this video? Yes. So I'm going to bring in my Game Boy Advance next season and some special hardware that I have, and we'll actually do a little bit of hacking with this ourselves because it's too cool. I need to play with it, right? So also, different member of our amazing community, who I've talked about before, Keeg. So Keeg has been writing a whole series of posts about using TinyGo with WebAssembly, and they have done all of their programming on a tablet because in theory they're on paid time off. So yeah, paid time off, and they're hacking on this awesome project. That's just so cool. Talk about labor of love. really, so they just released part 8 of this whole series about getting TinyGo to run in WebAssembly and create a whole browser-based application using nothing but TinyGo. And I guess Go for the server. But anyway, amazing stuff. I want to play with that a bit more to go through all the steps of their tutorial. But extremely cool stuff. Really excited to play with that. All right. So speaking of TinyGo, so we've had a lot of activity as far as cool new capabilities which have gotten merged in over the last week. And one of the ones that I find especially interesting is the ability to use TinyGo Test. So TinyGo Test is, as you might guess, similar to Go Test, except it uses TinyGo to execute the tests. And so this is a pull request created by Ika, the creator of the TinyGo project. And this adds the -v flag for verbose. That way, when you run TinyGo Test, you can get all of the outputs individually from the test, whether they pass or fail. So that's really cool. And this actually also can be run on bare metal. So I'm going to try to take advantage of this to modify the Tiny HCI, which if you have not seen that, Tiny HCI is our hardware integration server, hardware continuous integration. That's what we use when we're developing TinyGo, is we are actually running our tests against real hardware located at my secret headquarters. And so that's how we test TinyGo against real hardware every time that we are making changes to it. So, yeah, we take testing seriously, and now we can test the tests. That's so awesome. All right. So there was another pull request that's been sitting out there for a little while, and I thought maybe we would try to take a quick look at it. So Soy Pat, who has been really, really amazingly prolific contributor, adding capabilities for the Raspberry Pi RP2040 microcontroller. So this is a really cool microcontroller from Raspberry Pi. Let me turn on the light here so we can actually see it. Yeah. Wait, no light? Uh-oh. Oh, it's kind of dim. I think the battery's dead. Well, we can still see it. These, and one of them is it's got pulse width modulation implementation in the microcontroller. If you ever did any Raspberry Pi programming, you probably discovered that, like most single board Linux computers, it does not have pulse width modulation built in. You can simulate it by using things like Pi Blaster, which is a very, very cool piece of software I've made a few contributions to myself. But yeah, you need Pi Blaster in order to do that on the Raspberry Pi Linux computer. But we don't have a problem to doing this on a actual microcontroller. So let's go take a look at this pull request, because I know that there was a few differences between this and the other pulse width modulation implementation. So let's just take a look here and see. So we have the normal PWM definition, which is the ports that are actually on the Raspberry Pi itself. And then this is defining which peripheral matches to which pin. And if I look at the pull request, I think they say they tested it on the built-in LED. Let's take a look and see. How did they actually test this? I know that they did. Oh yeah, tested with the onboard LED. So that's really cool. That means we don't have to plug in anything to try this out. All right, let's go back to the code so we can take a look and see if it... So this is the changes to the machine package, which for the Raspberry Pi 2040 pulse width modulation implementation. And these are the different registers, apparently, that you need for that. We saw a bit of that when we've been hacking on the Raspberry Pi before. So let's see here. Set period. Now we're into the interface that's defined, that's needed for the supporting the pulse width modulation interface that's the same as all the other devices. Get, set, okay. Let's see, keep going. Quite a bit to it. And there's a lot of registers that you have to set on most platforms. On this platform, it's got plenty in there. Let's see. Oh, yeah, clock divider that we need, obviously, in order to support different speeds. We have to set the clock within the range of what the pulse width modulation block on the microcontroller can support. Okay, that's it. Not too much. So let's go and actually try to pull this in. Because of a squash or a merge commit, we're going to have to do a merge and squash. But let's first try to pull in this group of changes from this branch. So I'm going to, again, being very lazy, I'm going to just copy and paste from the instructions on the GitHub webpage for how to do a command line merge. So first we're going to check out. Let's go over to the correct place. Here we go. So first we're going to git checkout -B for creating a branch. The soy patch pico PWM is going to be the name of the branch, and it's going to be based on the current dev branch. So we switch to that branch. We're good. So now we need to pull it down. The only difference between this and the syntax that's just provided here by GitHub is that we're going to want to add a rebase. So we want to git pull --rebase. And then we're going to pull that down from the soypat fork of TinyGo from the patch pico PWM branch. And okay, we got it. All right, so we should, I believe, if we go and we, let's take a look here at the code for the TinyGo. Whoops, no, I do not want to get the new Go language server or the new VS Code update. I'm good on both of those, thanks. All right, let's see. PWM, here we go. So the PWM example has is set up for a few different boards, and none of them are, in fact, the Raspberry Pi RP2040. So we're going to have to go and basically tell the example which is the correct pins to use in order to implement, the same interface or whatever, right? So let's go and make a new, so that's one thing that is probably needed, at least to make it easy to run that example, right? We don't have to have that, but it definitely would make it easier. So I'm just going to copy, and then I'm going to create a new file, and we'll call it, let's see, RP2040. Go. And here we want to have a build tag for the RP2040. And let's figure out which are the actual pins that are supported for this, which didn't actually make it into this pull request, it would appear. So let's see. Let's go take a look at the files that were changed. These are the actual peripherals that are available. PWM 0 through 7. And I think we're looking for configure. Oh, yes, here we go. So we want to use, how does this integrate? Let's see. Let's take a look at the configure method. Down here. Oh, there we go. All right. So To configure, we have to take, we use a particular group. So that would mean that for our PWM here, for the RP2040, I guess we would say machine, for example, PWM0. I think that's what we do. And then which pins? Let's see. How does this work? Each peripheral has 2 pins. Some pins may not be available on some boards. Well, yes, of course. But we want to try to find the built-in. So if I look for the RP2040 pinout that I was looking at the other day, and let's see if we can consent to everything. Yes, I don't care right now. There we go. So the built-in, let's see, does this tell us anything about the built-in? Not really. Which one is the built-in LED? We can tell that if we just look at the board file for the Pico. And if we look at board Pico, we could see that the built-in LED is, we could just say .LED or GPIO 25. Okay. So I guess pin A would be, we could just say LED, maybe? What is pin B used for? Is this example pulse on 2 different pins? How does this work? Let's see. It sets the, it has 2 channels, so it's going to do it on, I guess we could just set a different pin. It really doesn't matter which one, as long as it's not one that we're already using for something else. So let's look for, some other random pin, like, for example, the pin for the analog to digital converter 0 or 1, GP27, let's just say. So if we go back here, we say B will be GP27, I believe. That should work. Okay, so I think we should be able to try building this if we just say tinygo flash, and we say target equals Pico, and then we want to use the examples PWM. No. Okay. So we can't just use the PWM group as a substitute for the timer the way that the other code worked. So it's not exactly plug and play. So let's look a little bit more closely to see what the example is doing. So it is calling PWM channel. It's got a configure. I think our problem here is perhaps that instead of passing the address, we just want to pass the PWM 0 directly. Okay. I think that is what we needed to do. Yeah, we were trying to pass a pointer to a pointer, and naturally that wasn't going to work. All right. So the code compiles. Now we can, I guess, find out if it actually works. So we're off to a good start. Here. We just got to plug into an available port. And let's... It looks like it worked. So let's go ahead and try to flash this code. Something happened. It's hard to tell if it's working. let's take again another look at the code and see if we can speculate on which pins may work with which PWM. Let's see here. RP2040 built in LED PWM. So let's see if we can take a guess. Arduino is usually pretty well documenting of things, but this is not quite what I'm looking for. The data sheets. Yes, of course. So let's look for the PWM page here, which is going to be deeply buried on, here we go, PWM. So this tells us all pins can be used, but not for all channels. So if we want to use the pin, which is the pin for the built-in LED again? It is the, got to go to the board file for the Pico and open that. And it's GPIO 25. So GPIO 25 is PWM channel, what is that? 4B. Okay, so what does that mean? 4B. Let's see. I guess that's PWM. Here we go. That's it. It's PWM 4, and then it's the B channel. Okay. So that means this should be 4, and then I guess we could put anything here. And this one, the B channel, the LED. Okay. So let's find out if, in fact, that works a little better. So one more. To our bootloader mode. Now we'll flash it again. And let's see what happened. I don't see anything different so far. No thing. This pull request is not quite ready yet. But let's not quite give up. Let's give it just one more attempt. So again, the built-in LED is GPIO 25. And so if we're looking at 25, that would be 4B. Channel 4B. Right? So going back to the example for the PWM, which I lost in here, but it's in here somewhere. Here we go. So it's going to configure it, and then it's going to set the two channels for the outputs and try to run them through the different duty cycles. Okay. And I thought I had it set correctly. Let's see. Pin A is whatever, GP27. And pin B would be the built-in LED, which would be 25. Yeah, really, none of those, I don't think, let's see. Let's go back and take a look at the pull request again one more time, just to see if maybe, just maybe, we can decipher this. So it's got the 7, it's got the group. Each peripheral has 2 pins. We are configuring it, and we're setting, maybe the channel's reversed. That's always a possibility, right? So let's try the original LED here on GP27 for pin B. just to see if, maybe. So we'll go back one last time. And I see nothing. Yeah, nothing at all. Just, nope, nada. Unfortunately, can get a little more insight, but it was close. I will make one comment, which was just to say, so far not able. Oh wait, hold on. Here's an example. This is a little different than the other example, the one that we're using for all the other code. So that's kind of, I'm not too sure. Well, I'm just going to mention, was not able yet. Was not able to get working with the PWM example in the main TinyGo examples. Or was not able to get working with the PWM in the main TinyGo examples. Some mappings are perhaps mappings are missing, and I might not have them correct for the Pico board. Just that way, if SoyPat does get a chance to look at this, they could tell, where we ended up. Okay, so let's switch gears now back over to the fun that we were trying to work on last time, just because I haven't given up yet, and we've got, I think, enough time to do this. Once again, my main man Lorenzo is here, and we're going to make a serious attempt to build a custom controller.
Hello.
What's happening, man? How you doing?
I don't know. I'm confused.
No, we're both fully vaccinated, so we're in the same social group now.
All right.
So it's too late. Or maybe I should put on my mask. One of us should. The other one, who knows?
No, yeah, it's okay.
All right. So last time we were making a real attempt to build this. Let me show for anybody who wasn't around if they hadn't seen it. So I have a special controller that I had built for flying drones that are Bluetooth drones. that was really dumb on my part. I should not have brought that board.
We lost the audio.
Uh-oh, we lost the audio.
Why?
It looks like it's going out.
Mm-hmm.
Oh, okay. We're good. False alarm. They tried to cut my microphone, but oh wait, maybe I'm too loud.
Eso no debería parpadear.
That's what the problem is. I'm a little too loud.
No.
Okay.
It's okay.
We're good. All right. So anyway, let's move Gopherbot out of the way because actually, wow, Gopherbot makes a really good light to solder by.
Ah, fantastic.
I'm going to put that back in. Yeah, that's one of the better lights that we have. Let's go back to that. You know. Okay, Gopherbot, you got a job now. All right. So, wait, what happened here? I don't see anything on the.
Other camera.
See, that's good. Hello, yes, and let's go back here.
No?
And no. Uh-oh.
Se ha congelado.
We lost the camera on the table.
Maybe trying unplug.
It was a view not long ago. Okay. No, that's good. Yeah, of course we lost the table.
Es la cámara. Esta cámara que se ha... Al poner la lámpara o algo se... Mira,
Ah, no,
se ha soltado.
se desenchufó el cable.
All right, let's see.
Ah, que estaba.
And let's see if it comes back.
No, se queda congelado, pero no pasa nada. Hay que volverla a cargar, no hay problema. Un momento, eso. No, pon... Eso es.
Okay, we're gonna almost there.
Un momento.
The cable came unplugged, no biggie.
Un momento.
So while we wait. Is it this one? Because I'm afraid our...
Wait un momento.
Oh, not quite. Almost
Un
there.
momento.
Almost there. Almost there. Stay on target. Stay on target. Oh, yeah. I mean, we should have known that it wasn't working before because look at that amazing light. Okay. So, maybe that's too much of a good thing. Well, we still have a little scan line.
It's this one probably.
I bet you're right. Probably, I would guess, we're better off without this. Yeah, okay. And then we'll get the Gopherbot's butt light.
No, un momento.
Okay, there we go.
No.
Uh-oh, something happened.
Enciéndelo.
How many engineers does it take to change a light bulb? I'm sorry, we don't give estimates.
No, but that's
Sí, ahí está bien. Sí.
That's okay. We're good now. It appears we're good. All right. So I guess the first thing we're going to have to do is this was the new board you brought. That way we can make another attempt to salvage our honor.
Ahora se ve.
Oh, yeah, that's a way to do it, but you're going to need your hands in a moment,
Okay.
so that's not going to work too well. And how long can the phone last? I guess we'll find out.
On the telly, you can see very
Right, but we have to see.
Yeah.
See, I know they could. The internet can see this. I know, but the internet doesn't have to connect these wires to each other. See,
Yeah, exactly.
they just have to make a few comments like, hey, do you guys know how to solder? And we're like, yeah, we swear we do. I'm a Radio Shack certified soldering artist. Yes, I made that up. Okay. Oh, so we're gonna need a couple of other items. We need a little sponge. And let's see where I have that. Because we need to do some desoldering here, real quick like. Oh yeah, last time we made up our own little. Last time we used the heat sink from a real soldering iron, whatever that means. And then we used that just so that we had a thing to stick it into so that we didn't accidentally burn anything like ourselves. All right, so we're off to a good start here. Can we do it? Yes, we can. Yes, we can. I'm still optimistic. Perhaps fatally so, but I'm still optimistic. All right. So the first thing we're going to have to do, I guess, is remove the... Actually, if you do it right here, that's pretty good. Like, you can actually see reasonably well. At least, I think you can. So I guess the first thing we need to do is remove the one pin that we soldered so that we can get the microcontroller back out.
Yeah, we remove everything and start from scratch. I think is the idea. We move.
But, I mean, there's only one pin that we soldered, I
except-
believe. The other ones are wrapped.
Yeah.
And the one we soldered was the ground. That's this
Yes,
one here.
that's-
So if we desolder that, I guess we can... I mean, look at that tip. Really sharp, right? Can you see how deadly that tip is? I know. I'm frightened myself. All right, let's plug it in. And I guess it's going to boot up. It says it's plugged in. So then we start heating up. It's upside down, so sorry about that. I don't want to turn it the other way because then I'll probably burn the cell phone. But it's heating up quite quickly to our maximum temperature. Not our maximum, but our setting. And the one pin that we have to desolder is this one. So hopefully...
I can hold you there.
Hopefully this is going to work. It's heating up pretty quick. It's already at 320 degrees Celsius. So that's kind of exciting. I would put it down
Okay.
because I don't want to be responsible. You can just leave it. I don't want to be responsible for burning you any more than I have to. Need to get a little
I
more.
wanted to help you to slide it out while you are desoldering.
If I can get enough of the solder
Can I
out.
remove those connections
Oh yeah, that's a good idea.
so that it will comes out quite smoothly?
Yeah, very good idea.
And 1, 2, 3, and now if you desolder this one, I trust you, okay? I got burned many times.
I'll be
so
gentle.
I will survive.
Okay, here we go.
So while you are, yeah, almost.
Wait, almost got it.
Yeah.
There's just a little piece left. It's probably on the other side of the board now.
Yeah, that's the problem.
So I have to let it heat up a little more. Okay, it should
Yeah.
pop out. Okay, we got
Okay,
it.
with,
All right, we did it.
Great.
We have extracted the part. Isn't this kind of like a really stupid commercial that Tim Cook did for Apple where it was the M1 chip?
I haven't seen that one.
Okay, I swear I didn't either. I only heard about it on the internet, I swear. All right. So if we go back to the original design was solid, I think. If we do the same thing, but this time the right way.
There is no way on this, so it's completely each hole. It's independent and not joined. There is no soldering.
And this was what we were trying to do before, is to put it in. There's a little
With the
bit.
USB connector up, I think, right?
Yes, exactly. There's still a little bit of solder on these pins, so it won't quite slip in. Let's see if we can just heat. Maybe we can just pick it up off there. I
Okay.
think I got enough. Because we just need to get enough so it slips into the holes, right? Oh, it's so close. Why isn't it going in? Because there's just a little bit of solder on that one pin.
Trying to push this.
You can kind of see it. Actually, you could probably see it through this camera a little bit. Pretty annoying. Now, another way to do this is the reverse of what we were just doing a minute ago, which is basically just heat up the pin and it maybe will slide in. If we just heat the solder up on there, just a little bit more. Oh, yeah, but if we clean the tip, and I see you clean the tip every time you solder
Yes,
and you
it's,
joint. You're really like very disciplined about that. I'm really lazy. I'm just like, okay, slap it in there, you know. Which
It became
didn't work this time. Okay,
perfect.
so yeah, cleaning the tip. Excellent idea. I'm glad I thought of it. Okay, so we got, this is where we want to put this. And then we said we were going to have a couple of different adapters, one on each side we were going to use for the two joysticks, which I guess in this case would be, we have, let's see, I have some more, I have a few of these, a few extras. I even have one that was bent already, but we're better off using fresh ones if we can, just because they probably come out better. And we need 4 for the top that we're going to use for the display, right? And I think I have one that's a length of 4 that I already cut, if you can find it. Well, I did anyway. Maybe it took off on its own. Just because it's the perfect size already and we don't have to cut anything. You know, that's always good. Oh, here's the display. This we're going to need in a minute. That's just interference from the phone.
Yeah, I was wondering if I can switch off the monitor.
Okay, it's not there. Maybe it's in this box. This is where my other parts were. I had one that we cut. And it was the perfect size. Well, we'll cut another one. That's okay. We have plenty. We don't have plenty, but we have enough. Like we have just enough. Barely enough. We have almost enough. Actually, we have quite a few. We have more than I thought. Oh, and this was the one, wasn't this the one we made to be a double length?
Yes.
We were going to use that for something. Yes. All right, so going back to the display. So we need, on both sides, we're going to need 5 pins for the joysticks. And each one of these has 8. So if we trim them the right length, hopefully, if I don't destroy them. And we'll get this one. Okay. Not quite. I hate when I cut them off and then you're like, oh, too short. Too bad. It's gone. Oh, you brought like some better colors.
No,
this
I don't
time.
know if it's better, but probably you can have a go. I don't.
But this
No.
is
No,
good.
The one you have, it's.
This is a pretty good length. So we need another one of those of length 5. So let's cut that off. Same way. Right? 5 pins. That leaves 3. And if we can chop it off at just the right length. It's got a little extra, but that's okay. Better that than too much cut off. I mean, we don't have an endless number of those, right? Okay, so I guess we could put these in now, right? And what did we say we were going to do? We said we were going to put them in, like, where did we put them in? We put them in a little bit further down so it'd be easier to reach. That's what we did. So this one has 26 pins. And if this is 5, then maybe if we move 5 pins down, so if we do it starting at pin 21, like that seems pretty good. And then we just have to bend it over appropriately so it's the right length. And the way I was doing that was, how did I do that? Oh yes, I bent it over, Well, when I did this, I did not have the other chip in the way. So let's just take that out. And this way we can bend it in using this little crimper part on the pins themselves, right? Because what we're trying to do is we're trying to bend it out so that we can bend it over, like so. That way we can bring this out a little ways, right? I'm not sure that was the best way to do it. Let me bend them back. That was not the best way to do it. I think what I meant to do was have it a little bit higher. That way I can, yeah, here we go. And then if I bend it over a little bit more, like so. Okay. I think this time I've got it. Like that. Because that's what we did last time, because we were going to do the breadboarding on the other side, or the, the wire wrapping. I think that's what we said we were going to do, right? Because we didn't, it would have been cleaner to do it this way, but then we thought it was less stable. As I recall, that was our thinking at the time.
Or maybe one inside. More, you were saying that move it from.
Oh, that's right. Move it over a little bit. That way it's
Yeah.
got more to sit on. That's right.
Exactly. We can also add some glue later, and it will become quite.
Because if we do it this way,
maybe just in line with the edge of the board.
yes,
Probably it's
that's a better plan.
because I don't know if it.
That looks pretty good. Let's see how the. Yeah, that actually works really well because you can plug it in. It's kind of snug. Yeah, that's really good. So if we just move that down a bit. Oh, how many pins was it over? 2. And then 5 down. Like, oh wait, 3. Like this. That looks pretty good.
Yeah.
And then let's just plug it in again. Yeah. I think that's happening. All right. So we just need the same thing on the other side, which was 3 over.
This one is longer, right? Has more pins.
No, it's the same number.
Ah, okay.
I flipped it over so that the little bit of extra leftover edge was just on the same side. That was the theory. Let's see if that actually worked. I think it did. Yep, okay. Here we go. That totally worked. This one actually worked better. And then same deal. We can plug it in. So now if we have them both plugged in, it will be like this.
Yeah.
Oh yeah,
It looks clean.
looks very clean
Yes.
with all the wire wrapping, I guess, on the other side. All right. So then, now we said we were going to solder in all these pins because that way it was more solid. Is that what we said we were going to
Yeah.
do?
Yes.
And then only the ground pin for which, how many pins do you need in between to have
I
enough
would
space?
leave at least 2 or 3, I would say.
So is that enough?
Let's try with the display in the middle and see how it goes.
Oh yes, the
that-
display.
That could
That is
be-
very important. The display could change everything.
Because this one is a narrow board, so
Yes. So we need, I'm going to try to cut them right in the middle. Let's see, hopefully I don't screw them both up. Okay, well, one of them is now a triple, and the other one, though, is luckily a 4. So, okay,
great.
so that's good. Do you have those other cutters? That's that way I can maybe trim off a little bit of this. Thank you.
Not sure if it's don't over.
Yes, don't overdo it. Story of my life, my friend. Story of my life. All right, that looks pretty good. And we're going to bend it in a little ways. And it's, let's see, 26 plus 5. Is that really correct? So A through Z, and then 5 more. Okay, well then. That means it should be here.
Can we? This is the middle. Mm-hmm.
And we can plug in the little board.
Yeah.
Just to try it out. And we said we were going to tilt it inward a little bit and reverse the display. That way it's kind of leaning up. But let's just plug it in so we can see how it looks.
Well,
And that looks pretty good.
maybe
You think maybe
Well,
not?
I don't know. I mean, if it goes a little bit outside, it's not that bad. But maybe having a go at how it looks like if it leaned inside could be. Let's have a look. Because in that case, you can also solder it. Solder it, glue it. What do you think? And we don't have to reverse.
I feel like it's one pin over, but
Maybe we shift the controller on the left.
so this is pretty cool because it makes it more compact.
Yes.
And that's always good, right? And also it means there's less things sticking out.
Mhm.
I mean, we're not committed, only if we go,
We can
flat.
switch connectors
no,
easily.
we can
Anyway.
change the orientation of it if we decided to.
Exactly.
But now that you had me change it the other way, it looks a lot better.
Probably.
This looks more like what you would expect,
compact. Yes.
more compact.
If you want to put it in a box, for example.
and you don't want to remove the display, I would remove the display for travel.
Hmm.
Anyway.
Yeah, but maybe if this fits into a, a
Yeah,
PLA box, you
you
print
can just
it.
pop it out.
Mm.
We still have
don't
to
even
plug
need
in
to.
the-
You don't even. You just do a small hole, a square hole, and it just fits.
And with no angle, that's much more likely to be possible.
Yeah, let's leave it like that.
Of course, we still have the thing with the battery. Like, if we have a separate battery, we have to plug it in somewhere else, which is, very doable. Right. Well, I feel like you talked us into just putting it in the original way, just flat.
And what about?
Just because that really feels like the most stable. The other one that's going to get knocked into, or this is the least likely to break if I drop it.
One
Right.
thing in that way, I don't know if this is the right position for the controller.
Maybe it needs to go onto the bottom.
On the bottom on one side, I was thinking, what else do we need to? Well, the buttons.
Yes.
Where do you want to have them?
The buttons need to be down here.
On the right side, they can be all on.
It's much easier to have them that way.
Or
because-
you should have one on the left and one on the right, the buttons, or they can be all in the same.
I am trained, my friend, on the creme de la creme of controllers, by which I mean the DualShock 3 controller.
Okay.
Like the DualShock 3, the button placement is really good. Like to take your finger off the right button, you're strafing while firing.
Okay. So.
It's a great way to go. So that means the buttons have to be down here.
Okay. So then no
And
question about.
if we do this, though, it means we could, for example, put this in like so.
Because otherwise, this can be.
And this leaves us a little bit of space if we wanted to contemplate the feature, which was, let me see if I can find it. I have a ESP32 board somewhere here. Now it's an actual board. It's not just a separate microcontroller, which is probably good because it's a lot easier to work with. I know I have it here. I had it here a minute ago because I wanted to see if it was going to fit. No, those are the buttons. Let's see, maybe I have it here in my bag of tricks. It's very possible. Let's see. I have one that's an ESP32 mini. And, oh, thank you. Yeah, that's a lot easier. I don't see it in here. Once I put it in here, no, it's not there either. I know I have one. 'Cause I specifically grabbed it and... Well, we're not going to put it in right now anyway. But... No, I don't have it. I have it, but not here. Maybe somewhere. Probably fell on the floor somewhere. Or... But it's very close to the same size as this board, which is an ESP8266. This is really similar size, and so it would be a similar sort of deal where we want to, be able to solder it on as a separate board and connect to the serial peripheral interface pins. So again, that's a future change that we could do if we do it this way. It's not like the most perfect of fit, but it would work. If we do it the other way, the original plan, which was 2 pins, 1 more pin. If we do it like the original plan, then we have a lot more room for this board somewhere like here, for example. for a future edition, just because we need to have some power. Well, no, it's going to have to draw from the same power.
If you
isn't it?
want, you can.
This is more if we need to flash it with some firmware or something. Anyway, this is not to be done right now. This is more just like a, if we were going to do this in the future, this would be a way. But we might, again, we're not worrying about that right now, so we don't have to care. So I guess we're just trying to decide, are we going to put this like this? Or are we going to put it on the other side down here? You know, the nice thing about this is it leaves us more room for future expansion. Like, it's very compact right now.
Yes, I think so.
I think we should do
We
this.
can even shift, if you prefer, this one bit, because it's not strictly necessary.
I can still reach in and hit the buttons if I have to reflash it.
Then it's fine.
And you have more room here to connect things. I think this is the way to go
Alrighty.
for now. Again, this is just our V1. So what do we want to solder first? I guess we want to solder all the pins on both of these. And all the pins on this. And then just the ground on this one.
Let's have a go with one pin for each thing, so it will have more stable, have a look, and then finalized and solder everything. What do you think?
Yes, I think that's the beauty of wire wrapping, is that you can actually do that. All right, so that being the case, I guess it's a lot easier. We just tack in one for each of these. Whoops, I guess we have to hold them in somehow. Do you want to solder them, or do you want to do the wrapping and I'll do the soldering?
Whatever you, it's fine for me. I follow you.
He's like, I just want to get it. I just want to see something happen. All right, well, I guess we'll just start with his. So it's got to heat up again. I'm going to follow your sagely advice and clean the tip. And so
Would you like me to help you with?
I just want to see that they're.
I trust.
I
you,
think
so
if I hold it in,
I'll do it for you. Don't worry.
I have another idea, because that. Here's a better way to do this.
Okay.
You need to just put something underneath that's the right size, which one of these happens to be exactly the right size.
Come on. I'll hold it for you.
This is easier.
All right. I mean,
We
the-
just
the
have to put
problem
one. We just have to put it on both sides. I see what you're talking about.
No, because then if you solder it, it will come out a little bit. So I will hold
Yeah.
it for you. I
Okay.
will trust.
Okay.
Okay, 1, 2. Okay, you can go.
I'll just solder on the top hole.
Yeah, just one. Can you?
Yes. I just get very close to it without my glasses, and it works perfectly. Oh yeah, this
That's-
tip is so much better.
Yeah.
Okay.
Okay.
And just any one of them, really, right?
Well, no, let's do the,
The ground?
Yes,
Okay.
sorry. Well, let's do this one first,
Okay.
and then the chip.
Okay, you ready?
Yes. Fantastic.
Okay.
Ground. Which one? I cannot see it. I think it's the second from.
It's on this side, second from the right.
Second from the right. Okay. Hold on. You can.
So it's this one here.
It's a pleasure with this board. Sorry, but I see that this and with this.
With this tip, yeah,
Yes,
it's
yes.
so much different. Like it actually,
Now we have it quite of stable, and we can also.
let's put it on the top here.
Yeah.
Mhm. Which was, I believe, here.
And if we don't like it, we can change it.
Okay. This one is longer, so it stays in
Okay.
more easily.
I won't risk my hands this time.
Okay. I know we were
No,
pushing
but-
it. I'll clean the tip.
No, don't.
Don't do them all?
No.
I know.
For now,
It's
for
true.
now.
It's true. You're right.
Just-
I know. I'm like all excited. Like, saw they're all the
Yeah,
pins.
I
Boom,
know,
boom, boom,
because
boom.
it's
But that's
addictive.
what the whole
So-
point of this
so-
wire wrapping is. Wow. Okay, that looks really good. I think we can probably. Okay, now the ground. That's what we needed. We needed multiple pins for the ground. That's what we were doing.
Yeah, we can use one of those rails and decide which one will be the ground. For example, the one
Well,
on the
this
left.
is the reason why we.
If you like, I don't know. Other way, we can choose another approach. No,
Well, we made it a lot closer now.
if
Than it
if
was-
any of these one goes to ground, which is quite large, we can derive the other.
Unfortunately, the ground is on this side right here. It's the one pin I soldered.
Yeah, but we can do up to 2 wraps on one of those small.
Oh, so make it just choose some area to make the ground.
Yeah.
And this is where we were going to use one of.
We can derive 2 grounds, one here, and then, sorry. Okay, one here, and the other one's from this one, which is longer.
Because on this board, we chose to do that. Yeah, we did that, I guess, on both sides, is what we said. And we pushed down the pins. I think that was still a good idea. But that was based on a slightly different layout of where this board was going to be. Because we had more width.
Yeah, it's true.
So we can't do that now anymore.
We don't need.
So you're just saying just pick a
The-
rail
this-
down here to make essentially.
I wouldn't do the rail in this case.
No, what
Let
do
me-
you,
let
what
me
do you
think
think?
about it.
Yeah, what do you think the best option?
How many grounds are we going to connect?
We need one for each of the joysticks.
Yes,
We need one for the display,
yes.
and then we need one for all of the buttons.
Yeah, we have plenty because look on one of those, which are the same length, we can do 3 wraps. On this one, we can do, I would say, 2 wraps. So this one.
So we have,
We can.
but we
move
still
around.
need to have more than 2 wraps for the ground. I mean, we need to have some place that we make a rail of some sort,
Yeah.
and that's what you're suggesting to use
Where
the
is the
side.
ground in here? So from here, we can move to this rail, for example, and do this one the ground rail, and this one we will do it the.
Is that better? Is that actually okay to be touching the ground?
Good. Well, with these voltages, and I haven't got much problems.
I just think it's maybe better to not have it the whole edge be the ground. That way, if something shorts it, we don't fry the thing out.
All right.
Well, just because I like the way we did it before. I mean, that was actually really clean. And if we put like a ground down here, essentially. Because it's not right in line.
Remember how we did it? We pushed. Sorry, 1 second. So we push all those out, and then we will stick it from the bottom and solder it from the top. So it will goes. But can I?
Yeah,
I will do
absolutely.
it now. It's like this, and we have more room for. The other day was.
Oh, yeah,
You
that's
remember?
right. I do remember that now. And we had like, here's a 4. This is a 3. But we said we wanted 5 because we needed 5 things to plug into.
Yeah.
Actually, we needed 6. Is this a 6?
It's 7, I think.
Oh, well, that's plenty. Because then we did just the reverse.
Exactly.
And that way we just said, okay, that's
I mean,
the
we can
ground.
solder this.
And we can move it over a bit more if we want to, like, make it so it's not quite so tight, for example. I mean, we don't have to make it right in line with the ground. But if we did, the problem is it's too close, right?
Yes.
So if we did that same idea and we just move it down,
That's perfect. I mean, it's one step, but it's not a problem.
it's a few steps.
I think.
But I mean, it doesn't actually match up to anything specific. We could put it in pin 13, which since you rarely use that since it's the LED, like that maybe.
Okay, so we'll hold it for you and you solder one.
I saw there, and this is what we did before, where we had the one jumper across them, as I recall. So yeah, if you hold it,
Yeah, hold on. So you are soldering this one, right?
Mhm.
Okay, you can.
you hear the hissing. That's how you know it's real. These special effects they're just all too real. Everything's all good until you get burned. Then it's like not funny anymore.
Just one.
Yeah.
As usual.
Yeah, because we have to. It's not hot yet.
No.
Have to wait a minute. It's heating. 325. 340.
Yeah.
I really like the display. It's so cool. All right.
Displays are always fantastic.
Okay.
Perfect. So we have this one too.
Okay. So now we just need to find another piece of wire to jump across them all, like we did the previous time.
Another.
I used a resistor. I had like a spare, just an extra resistor cable, because it was not too. Actually, this might work.
Yeah, you were saying this one. You can.
Oh, yeah, this would work. It's a little. The problem is it's not quite. It has this extra part on the end.
Well, I don't know, maybe it's not long enough if you got it.
Exactly. But I have a resistor wire here somewhere. I had an extra resistor I was willing to sacrifice for the greater good of this controller.
You proved the resistor wire was the best the other
Well,
day.
it was the best we had. I'm sure there's probably a more proper way to do this.
But if you don't have one, we can have another go at the.
No, I have one. I have like a bag of resistors here somewhere, if I can find it. No, that's the bag of LEDs. Let's see. I mean, I can always break down and actually take like a nice resistor out of the box or the resistor kit. It's just like pick one that I don't use much of. Let's see here. 1K resistors. Oh no, not those.
Well, they are in abundance in nature.
It's true. Like, I know. I'm like, which one of these? Like, come on, pick a resistor. Okay. Sorry, resistor. It was someone's turn, and this time it was yours. The fact that we're not using it for resistance, but that we're using it actually for mho instead of ohm. Mohs are conductive units of conductance instead of resistance.
The reverse of ohm, yeah.
Yes.
I'm not used to listen to that, but yeah.
I'm not sure if I've ever said that word out loud. I know it exists, though.
Mo, it reminds me more.
Like Curly and Larry?
Beer.
Three Stooges? Yeah, that's probably the level of technology that we're at here. Is definitely Three Stooges. Okay. So now, this was the...
I'll hold it for you. Don't
well,
worry.
it's easier to just... Well, actually, maybe. Because we just want to put... Whoops. The main thing is to... Once you get one of them on there, then they can all just plop on. The trick is to not... Well, first we have to wait for it to heat up. Yes. Okay, yeah, you got the right idea. 267. 300. Not at full power yet. Actually, I've never taken this thing to full power. I think that's more heat than I need. I mean, for this kind of work. Okay, 360. We're good. Let's go in.
Alright, so the first one.
Yeah, fantastic.
We get the second one
Just-
without the first
Oh,
one.
well, we
moving.
should. in
Probably
this
go
case-
to the other side.
Yeah, we can.
Yeah, that's almost for sure true. Okay. Wow, it's really slim, this bit. It's so tiny that it barely gets any on there. Well, you're not supposed to inhale this. Don't do this at home, kids. I mean, breathing, that is. That's how I used to do it, is I would just build up a bridge of solder between them. Which is, probably good.
All right. Seems like there's plenty on there.
Yeah.
So let's.
That's good.
Okay, let's take a close look. That. So if we wrap the, so we're going to need another one of these for the power. We've got the ground, but we need the power
Yeah,
because we need a power rail.
that's.
Should we do the same thing that we just did to make a power rail in the middle here,
I
or?
think it's a good idea. I don't know about the layout, where to position it, but it looks like that's the way to go. Do we have one of those rails from the other day that we pushed, not to sacrifice one of the existing?
No, we already had soldered them in.
Okay.
So, but that's okay because we need, let's see, how many do we need? We should just make it the same size.
The same, yeah. We can always
Yeah.
find if we need more, we can get more.
Yeah.
So, shall we break it? Well, you do, because it's.
Isn't this the right size here? Yep.
You can.
How did you do this? You just,
I think we can do it with that one.
okay.
Let me try. Let's
Sure.
see if it works.
'Cause that looks clean, and it also seemed like a pretty solid connection.
Oh, shit.
And we can use the other side of the resistor lead.
Okay. Looks like it works.
Seems legit. And should we put it like far on the other side, or kind of next to it, or where do we want it?
No, we don't want to sacrifice this area, so maybe not more than. I think this is fine. Well, a bit lower. That's. What do you think? Too much space, maybe.
Well, I don't want to have it too close. And this is where the clock and the SDA are. So if we move it up a little bit, I think we'd be better off.
Right below the display, maybe. Just align.
Oh, good idea.
Let's see. We can hide it.
Well, it can go down a couple more. Like here. Well, let's bring it back up one more.
Yeah, I agree.
It was just a little too close. Okay. So then we just tack one again.
Yes, I'll hold it for you.
Thank you.
Hold on.
Surgery.
Let
Let the
me
tip heat up. Back to 360.
we need, yes, solder one.
And then we'll need to clip off another lead.
Probably.
Yeah. Okay, that looks good. Take off my glasses. We're up to 360. So let's
The one below,
this one here. Okay.
All right.
Nice hot tip, clean, sharp tip. It's so easy compared to some of the tools I've used are really bad.
Where's the resistor?
Oh, so here it is. So long. And the same sort of, it's too short. No, it's just
Right.
like, it's a little short.
No, it's fine. I think with one. Look, I can hold. Well, if you, I don't know. I think it's perfect. It's perfect.
With a little blob of solder.
Yes, it
As
will.
long as I do it very gently.
Yeah.
Hopefully. We'll see. Because this will give us the power. So, it's still hot. The sleep doesn't hit right away. It takes it like a little minute. Actually, I think I'm going to try this. Shoot.
It fell off.
No, it's still on. It just it moved in a way that was undesirable.
Hold on. I will.
It
Where
came
is it?
off. It's
It
on
came
the
off.
sponge.
Ah. Let's do that.
It's a little bent
Yeah,
now.
and I don't like that.
Maybe we should
Holy
cut.
moly.
Let's just cut a new one.
Oh shit.
Yeah. Time to cut a new one.
Okay.
So let's put down this other iron. Yeah. Well, you know, to make a few circuits, you're going to have to clip a few resistors.
Yeah, sacrificing.
That's what my drill sergeant told me. And, or somebody. Maybe it was my auto shop teacher. I don't know. One of those people who tells you how you're supposed to do
I
things.
mean, I came out. I got it.
But it's kind of bent.
Let me see if we can.
I know, don't. He's like, I don't want to waste
Yeah.
materials.
Exactly. Copper.
Because it
is-
was always kind of short. It's a little bit better if it's longer.
Okay.
If it's a little bit longer, it's a little bit better because it's a little bit easier. Not too much longer, but like that.
But we can cut it afterwards anyway.
Well, a little bit that protrudes is not too much of a problem. But as you saw, if it's a little too short, so you have the tweezers, you can adjust it more easily.
Well, but from that way.
Yeah.
Probably.
Actually, do we need to cut a little piece off? It looks like it. It's a little too long. Let's just trim a little tiny chunk off.
But I think that. Oh yeah.
We'll be happier if we do.
No. Okay. I thought you were.
Huh? No. No. Definitely wasn't going to do that. Okay, I think it's a good length now.
Tweeze.
Oh, still a little long. Yeah, I think it's good enough.
Perfection.
Otherwise, like the power pin sticking out a little bit further, definitely something can go wrong with that. Okay. Still 360. All right, this one we have to get them all in one shot. Oh. Uh-oh. Not good. There we go. Haha. That's not exactly what I had in mind, but that'll work.
Okay. Hold on a second. I will change the. Probably if I rotate it that way, you will work better. Try now.
Okay, yeah, now we got it. I can just tack the other ones down. There we go. Oh, a glob. A glob flew and hit another
Yeah.
pin.
I had those.
Oh, there's another one. Well, we weren't going to use that hole anyway. That's why we didn't make these too close. There we go. And just a little bit more. That one's cold. That one, these are a little cold. And okay.
Great. Well,
Make it shiny.
Except the last one.
Okay.
Yeah, that is perfect.
All right.
I think we have it now.
I think we have it. So, if it's true, we should. That's a little bit much, but that's okay.
Ah.
You can use that one to connect to the actual power.
Okay.
Just like that one, this end you're going to want to connect to the actual ground, right?
Yeah. Right.
So now we're ready to wire wrap. And I guess the first thing is the ground, the power, and then the SDA and the clock. And we should be able to see something appear on the display. That was where we got to last time, when things all of a sudden went bad. Actually, it wasn't all of a sudden. They were bad the whole time. It was just suddenly we noticed it. Right? I can put the resistors away. We're not going to need those anymore, I hope. Yeah, this little pack of resistors, I think it's from Spark Fun, maybe?
It looks,
Yeah.
the colors looks like the Spark Fun red.
Yeah, that's a handy little kit. I have a couple Adafruit ones as well, and they're pretty great. I mean, I've used them so many times. Oh, wow.
No, just to,
So organized.
yeah, because otherwise
Yeah.
we'll try to reuse them.
And we shouldn't need the solder sucker, aka the desoldering tool, hopefully.
Now, if we're going to plug this one that way, we will do the signals and then we do the power.
Sure.
Okay. So, data orange.
SDA, which is the third up from this side.
Okay. Third, sorry.
Third here.
Ah, okay. Okay.
Third from the bottom is the data.
Let's see.
Threading a needle.
Yes, exactly. Oof. I don't like it.
Third from
There
the
is
bottom.
so much reflection. Third
There you go.
from the bottom. Sorry, but it's not.
Oh, no worries. I should be holding the board while you do it.
No,
He's
no,
like,
no,
no. Just stop. I'll hold my own board, thanks. Kind of thing.
Yeah, more or less is like that.
I'm going to unplug the soldering iron. because we shouldn't need it more now. Hopefully. I mean, we'll need it for the buttons, but we don't need it for this part of the test.
All right.
Oh yeah, that looks nice.
That was
So third from the bottom.
okay.
Stay there.
Then 1, 2, 3, 4. Well, whatever. I think it came out quite clean.
Yeah, look at that.
So we will go to the we say data SDA, so
That's right.
the extreme left. This length more or less. My side and my hands.
The little stripping tool is so cool.
Yes, all in one.
I remember doing this with a friend's Z80 based computer kit.
Fantastic.
Oh man,
Good times.
Oh, yeah.
SDA.
I don't remember if we had the actual chip. I think we had everything for the kit except for the microprocessor. Sorry.
I will give a little push. Okay, and that's it. I will use everything. I think I'm doing more than required, but anyway, we don't.
Yeah, but this is for avionics. You know.
And then we can.
I mean, we're flying things with it. Over engineering, of
You're
course.
absolutely right.
Of course,
This. Okay, now we do the clock.
There's many experimental aircraft that people sit in and fly off the ground, which are not as well put together as this, which is really scary. There's quite a few that are, though, actually.
Of course, there is no limit to.
The only limit is time and budget, my friend. Time and budget. That's the only limit. Imagination, we have aplenty.
On the chip,
On the chip, it is clock, which is the pin directly up in this direction from the data. So it's the fourth pin from the bottom.
Okay, just next to it. Perfect.
Exactly. As usual, Adafruit, their board layouts are very nice. They've really thought through the typical use cases that most, I guess hobbyist prototypers would need.
We give it a little push. Yeah, that's fine. And then we do the same.
Same thing to the other side.
And I think it's the next one.
Yes,
Or clock, yeah.
exactly. Next one over.
Now you can try. You will do now. You have seen it twice, but
Okay.
you will remember it how it's. I will
First you strip about the length of the
and I will go from here without pushing too much, just with the weight of the tool, and then gently.
and then holding it with your left hand so it doesn't move,
Yes.
at least not too much.
And then I will. Oops. Well, it's not the same length, but it doesn't.
Close enough.
Yeah.
Close enough.
And we have to
Okay. So now we need
power.
the power.
I will cut it for you. Would you like to see it? Probably you would.
Yeah.
It's much
Gets a little closer. Okay. And so the power, we need to actually do two of these.
Will you start with the ground?
We need to go from the power from the chip to the power rail.
See if I have a black one.
So we need two of them. So the power on the chip is the second from the top here. So we need to go from here to this power rail. So I guess going this way. I guess we'll go from the second from the top here is 3 volt.
Yeah.
And so we want to go from here to this rail, which is what we're going to make power.
Right.
Because then this will be ground.
Right.
So we need to go from here to here.
Yeah. So you start with the power, then I will
And then
start.
a separate one will jump from here to the power on the display. Right?
Yeah. Yeah.
I mean, that's the proper way to do this, right?
I mean, if you want to, yeah, the idea is to start. Just connect the power to the rail, and then everything else will be powered from here. So we do it once, and we forget about it.
Okay. All right.
I will start the length of this.
So the length, how much do we need to have for stripping? So it's like this,
Yes, more or less.
2 of those.
Very approximate.
So like 2 of those, this.
No, it's just one.
Well, no, because we got to strip it on the other side. So we need this.
Yeah, but
I think. Let me
wh-
just see if I have this right.
What I
So
will
we
do.
need this
Mm.
plus another one of the same size, and then the length of the run, approximately. So like something kind of like this.
But I will cut the second end after.
Oh,
Yeah.
I see.
Yes, I
Of
will.
course.
Yeah.
Right. It's not that hard. I'm making it much harder. So actually, what we just need
Even
is
with
to
your-
go with the
No,
length.
this is too long in my opinion. That a bit more than that, and it's fine. Exactly that.
So then we just. Is that the side we put it in? Yeah.
Yeah, they're right.
Slip it in there. And then just. Well, how do we cut it? Oh, yeah.
Slide it down. No, more. It has to do some sort of click when you just slide it down the cutter.
Oh, I see. Like so.
Yeah, nice
Oh, cool.
feeling.
Oh, yeah. That's really nice. Okay. So then we thread the needle. Let's see, where's the hole?
This is the difficult. It has 2 holes.
Oh, no
One
wonder.
in the middle, but it's not this. The big one is for the pin. There is a very small on top where the rail is, where you have to actually insert the wire. So it's very tricky. That's the most. Yeah, that's perfect. You nailed it at the first attempt.
And then we have to just hold it over.
No.
No?
Okay, yeah, you did the right thing, but not fold it. Just
Just kind of bend it a little bit.
no. Let me. So it's just the plastic here. The wire, you bend it a little bit, and then by holding this, you insert into the pin.
I see.
Okay, exactly. Keep it.
Okay. So we've got to get the right power, which is the 3 volt here.
And then very gently, without pressure.
And just gently turn it, keeping the one side not moving. Oh yeah, I feel it's something happening.
And until you hear the click, which means it's done. Well, I think it's done,
I didn't hear a click.
but doesn't matter.
Oh yeah,
Looks good.
okay.
Looks good. Perfect.
So then same thing on the other side.
Exactly.
It's
Now
just
you can
now
cut.
you
Yeah.
want to make sure the length is about enough for the,
Exactly.
so about like that-ish. That's too far. Wait. Because we want to be like this plus this length. So like here. Okay, thank you. Thank you, doctor. Okay. So we'll use this for the other side.
The
So
rapid
now-
surgeons.
We strip it. Oh, the length, about like so.
You can take with your nails as well. Usually it comes out.
Yeah,
This is very...
that's the kind of thing I inevitably screw up.
Okay, perfect.
At least in my experience, I do the wrong thing, and next thing you know, I've destroyed it. Okay. could be on the end. And like so. I probably would have put it below the other ones if I could do it again. I think I heard a click. Yep, I did. Alright. I think it's not the best wire wrap job.
It doesn't let me.
But it's
Well,
probably-
I cannot see very well. It's no, because of the solder. No, it looks good. It's just a bit rising
It's
because
not.
of this of the blob.
It could be
Of the
better.
glob.
It could definitely be better, but it could also be worse. All right, so now we need to do the same thing from the power on this, which is this pin, over to really any one of these, right? But since we're going to want some for the joysticks, maybe we want to like pick one in the middle. Or I don't know. How do you do
I don't
this?
think there is really. Let's start from. Doesn't really matter. Yeah, because
Okay, this is actually really
we
fun.
usually tend to do this kind of movement, so running around and leave plenty of space anyway. Oh,
Yeah, this is really fun.
I think so. I love
And
it.
I really like wire wrapping now. I'm totally hooked.
It's addictive,
I totally see why this is like.
and
It's more like jewelry than.
for certain things, it's I think it's the ideal, and the hybrid stuff, it always works, mixing best of both worlds.
Yeah, I could definitely see that. Because.
We use less lead.
Yes, well, I've been inhaling lead fumes for too long, and that surely is not good for you.
Well, but it has some really practical advantage in some case. Well, over the breadboard for sure, because of the stability of the connection.
Well, I'm already over breadboarding for a lot of things.
Ah.
I've been using breadboards for things that you shouldn't use breadboards for, and like the cables keep coming out, and it's very frustrating.
Absolutely.
And it's not necessary. Like I was thinking how many I want to build some boards to use for the Tiny HCI, because I have all these breadboards and they're a little flimsy sometimes, not just sometimes. And the problem is the cables come out at exactly the wrong time.
Yeah.
I mean,
Oh,
that's
it's
just,
always like that.
that's just a given. Okay, I see what I was doing wrong.
I should point the camera better because it's a bit.
And same thing here. Right, we just, because there's a little extra glob of solder, it's not as tight, but it's still good enough.
Sorry. I'm
No worries.
just trying to.
Okay, I have the power. I have the power!
Yeah.
Now
Now
wait, now, is this
now
the
we
block?
need the ground. Yeah.
All right, here's the ground. Oh man, I'm on fire. I can't stop now. I'm like totally hooked. It's like, this is like those labeling machines, like you start using the labeler and you're like, I can't stop labeling everything.
I agree.
So now it's like, I want to wire wrap everything.
I made the mistake of giving the labeler to my daughter.
And like everything's labeled, but with labels that maybe you didn't want
So-
labeled. Like her names for things, yeah. And this is really cool. Okay, so the ground, same deal. It's a second from this one here. Okay, I'm getting slightly better at this. I'm not saying I'm good at it. I'm just saying I'm slightly less
You
bad
are
at it.
mastering it already.
I'm slightly less bad. Okay, I'm going to try to go for a tight connection from the ground to the... I'm going for it. I know. probably a mistake, but I'm doing it anyway. I'll give a little extra just because that way I know. Because I saw someone in the video do this once, and I'm like, okay, I should be able to do it that kind of tight, clean wire wrapping.
I learned it from a YouTuber called Andreas Spice. He has a very beautiful channel for makers.
I don't think I've seen that channel, and I should.
Absolutely.
Okay. Did I pass the audition?
Wonderful.
Okay, we just need one more cable, and we should find out whether this actually works.
Wrapping highways.
Oh man, this is so okay. But I dropped the black cable.
Doesn't matter. Well, I will have a look, but if
Or maybe I
we
used
have,
it all because
it could also be that.
I didn't use very much of it.
Here it is.
Yeah, I didn't use much. I used so little that there's no way I could have used it all. Okay, so same deal. Strip an end. Yeah, it doesn't have to be perfect, but when you see these people's wire wraps that are so perfect, you just think like, wow. I mean, it's kind of like jewelry,
Absolutely.
like beading. You know, like a mosaic or
Jacquard
mandala or
machine.
something.
How do you call the texture of the?
I'm gonna go this way. Yeah, like a mandala or one of these geometric mosaics that they have.
Fabrics. The fabrics.
Batiks?
Yeah.
Suddenly now I wanted to go the other way, but because these cables are all going this way, I have to do that. See, that's a trap. Now we got to go like this, and then one little bit extra here.
I'm sorry.
Oh no, no worries. I'm addicted now. I can't stop.
I know the feeling.
It's like my entire vacation. All I'm going to do is basically wire wrap now. Like that's all I want is a wire wrap kit. I'm gonna have to order one. Like if your kit is missing,
there is a.
if your kit is missing, you're like, what happened to my kit? Like, I think Dead Program stole it.
There is a pistol. I mean, that rather than you turning the tool, you just.
Oh, I'm not. I'm
but
not that good yet.
That's too much. I
I don't think I need that yet.
It-
You know, that's for people who actually know what they're doing. I'm still just a, enthusiast. But maybe I'll get one of those because, come to think of it, I really do have a lot of wraps that will have to be done. Okay, so I'm just looking to make sure that there's no. Yeah, because if you do it right, then the insulation, like this one, I didn't do it quite perfectly. I'm not sure if that's fixable. Basically, like if you do it so the insulation is actually very close, then
Well, if it's not insulated, they may touch the other one, and that's not good.
right, and that's what I did. That's what happened here, for example, which of course is the ground, so that's unacceptable.
Mm-hmm.
What happened to those tweezers? Here we go. So, like, this is not actually good. I mean, it looked neat. It seemed like it was tight, but in fact, well, maybe if I just pull it a little bit, yeah. But, like, it's okay now, but now that I've learned a little bit more about the wire wrapping, I realize that, like, the ones you did are better, of course, because you have the right little space between the insulation and the wrap. In any case, though, we should be able to test this now. So if it doesn't explode, if we plug in the battery, like any battery, actually, or just a cable, let's see here. So I think we just need to go to the TinyGo drivers, and if I flash TinyGo flash target itsy bitsy NRF 52840, and we flash the examples SSD 1306. Which one is it? The I2C 128 by 64. Yep, that should do it. Okay, it's flashing. And observe. Oh. On the fact that we had completely used the wrong board, and this time, like, we're really close to having a flyable thing, because the not really close, but much closer. We have to connect 10 more wires for the joysticks. And then we have to connect, we have 4 buttons, each of which has a pin and a ground. So 8. So we have 18 wire wraps and I guess 8 solder joints. And if we do that, we have the ability to actually turn this into a flying thing. Wow. Okay. Well, I guess I have my homework. I have to get a wire wrap kit now because this is just too fun. I mean, look at this thing. This thing. Wow. Well, awesome, man.
Fantastic.
Thank you so much. I
Has been
really
a real
appreciate it.
pleasure.
Oh, man, that is so awesome. Okay,
enjoyed it.
that's
Thank
it.
you.
Now I'm hooked on wire wrapping. All right, so let's see what... Today we redeemed ourselves. We actually got the wire wrapping prototype done. Before that, I got to take a look at a couple of pull requests. The pulse width modulation pull request that is on the Raspberry Pi, not quite ready for prime time, but it's getting close. So hopefully by the end of the summer, we're going to have full Raspberry Pi support for all the peripherals and some other stuff. And some other fun new pull requests that I see coming in for other hardware as well. So on that, everybody, you have a great summer, what's left of it. Thank you so much. Gracias a todos mis compañeros. Thank you to all my colleagues for what's been a really great run. We'll be back after summer vacation with a new format, new awesome things, new toys, and maybe a new look. Maybe I'll even cut my hair. Anyway, goodbye, my friends, and see you in the fall. Computer